Hello and welcome. Listen to the following two extracts of music and see if you can hear the difference. In both extracts, the rhythm consists of alternation between longer notes and shorter notes, and both extracts share exactly the same total duration of the long note followed by the short note. The difference between the two extracts is that, in going from extract A to extract B, every long note has been shortened by 1/60th of a second, and the subsequent short note has been made to start that same 1/60th of a second early. Now, incidentally, the lowest note in these extracts of music has a frequency of about 65.4 Hz. So the amount of time that has been transferred from the long note to the short note in going from extract A to extract B is approximately just one cycle of the lowest frequency present. And yet, this transfer of just 1/60th of a second from the long note to the short note is enough to have a clearly audible effect. This is a manifestation of the general principle that whenever you have some fixed quantity that needs to be divided into two portions, the ratio between the two portions is very sensitively affected by small adjustments to the division of the original quantity into the two portions. This is the reason why, when you have some amount of food that you need to divide into two equal portions, and you make your first attempt at the division and see that one portion is significantly bigger than the other, the amount of food that you have to transfer from the bigger portion to the smaller portion to make them roughly equal is surprisingly small. Now, in the case of the two extracts that you heard, the total duration of a long note and a short note was 1/4 of a second. In extract A, the ratio of the duration of the long note to the duration of the short note was 2 to 1, but in extract B, the ratio was 1.5 to 1. And I'll leave it as an exercise to the viewer to show that this does mean that the amount of time that was transferred from the long note to the short note in going from extract A to extract B was 1/60th of a second. Incidentally, the extract that you heard comes from a piece by Beethoven, specifically with the rhythms as in extract A, although an exact tempo isn't specified. And this piece by Beethoven has as one of its core themes the exploration of rhythms that involve divisions into threes, and as part of that, rhythms involving 2-to-1 ratios. And it kind of bugs me when I hear performances, even by world-class professional pianists, that sound more like extract B than extract A. Now, the general idea that ratios depend sensitively on how the total is divided between the two portions can be understood mathematically, namely, if we let x denote the proportion of the total that is taken up by portion 1, and we let y denote the factor by which portion 1 is greater than portion 2, then we can construct a mathematical relationship between x and y, and I'll leave it as an exercise to the viewer to check that this equation is correct. And we can plot a graph of this equation, which I've plotted in Desmos. Now, in this graph, we have the same scale on the x-axis and the y-axis, and you can see that as x increases from 0, the gradient of the graph quickly becomes very steep. And this steepness represents the sensitive dependence of the ratio. Namely, it means that if I have a small change in x, representing a small change in how I've divided the total into the two portions, then this leads to a comparatively large change in y, representing a comparatively large change in the ratio between portion 1 and portion 2. Okay, well, I'll leave it there. Thank you very much for watching.